Yeah, my name's Kolbe Kegel. I'm a customer success engineer here at PingCAP. That means I spend a lot of my time working with prospects and potential POCs and other people who are just trying to figure out how to make use of all that technology that Ed just discussed. So what I'm going to do is, well, first of all, I'm going to share my screen. Hopefully that's big enough for folks. If there's any concerns, just go ahead and say something in the chat. So I'm going to talk about TiDB in action. And here's what we're going to look at during this demo. The first thing I'm going to do is deploy TiDB cluster using TiUp, and we'll talk more a little about what that can do for you. After that, I'm going to start HA proxy, which is just a very simple load balancer, because we're going to have multiple of the TiDB server component, the SQL speaking front end. Then I'll start TPCC benchmark load just to put some action onto the cluster. Then we're going to check out the cluster status using our own built-in dashboard and the Grafana dashboards that we ship as part of TiDB. We're going to actually dynamically scale out the TiDB cluster to add additional TiKV stores and to add TiFlash, the columnar component that Ed discussed. And then we'll show just a little bit about what HTAP can do in TiDB and some of the capabilities built into the product with regard to HTAP. So let's flip over here to my terminal. So the first thing we're looking at here is just a big list of the instances that I've deployed. So I've deployed 16 EC2 instances. I wrote a little script that does this. I have 4 instances in each of the 4 availability zones in the US West 2 region. So let's take a look at this topology file that we're going to use to deploy the cluster. So TiUp clusters are defined in a simple YAML file, and YAML is really easy to generate using a tool. This is all dynamically generated by a tool I created, but there's nothing special in here, right? It's just a couple of real simple parameters. I'm keeping my Grafana server and monitoring stuff all in this host that I'm going to be connecting from. I have 3 of the PD placement driver servers. Those are on 3 separate nodes in 3 different availability zones. We're going to have 3 TiDB nodes, and then I'm going to have 1, 2, 3, 4, 5, 6 TiKV server nodes to start with. But we'll look at that in a little bit more detail, but let's kick off the deployment right now. TiUp cluster, deploy, I'll call it test 511, and then we give it that resources.yaml file. So the TiUp cluster deploy step is actually going to connect to all of these machines, and it's going to download all the packages we need. It's going to copy all the configuration files over, and it's going to have everything just totally ready and set up to start the cluster in a moment. So another really cool thing you can do with TiUp, I saw a question about this actually. While I'm waiting for this cluster to deploy in my cloud environment, I'm going to flip over here to my local machine, where I'm going to show you this really cool feature called TiUp Playground. So this is a fantastic way to get a really easy start with TiUp. So TiUp will run on your Mac, it'll run on your Linux machine, and you can just download TiUp and install it, and then execute TiUp Playground. And what that does is it will find the most recent version of TiUp that we've released, the most recent version of the TiDB platform that we've released, and it'll actually create a real TiDB cluster all running locally on your laptop. And by real cluster, I mean you're going to have a TiDB component, a PD component, a TiKV component, and I think it even starts TiFlash. So it's that easy. I mean, it takes several minutes to start up, and you can begin connecting locally to a TiDB cluster on your local laptop. So that's a really easy way to just get a quick start with it. Of course, for any kind of real usage or benchmarking, you're not going to want to do all that stuff on your laptop. But the good news is that the only step you have to take to get from this to a real cluster deployed on real machines is to make one of those resources.yaml files and start your cluster. So we've already deployed the cluster. After deploying is the process of copying the files out to the nodes in the cluster. So after that, we can start the cluster. And that'll happen just with this simple TiUp cluster start test command. So when I do this, it's actually TiUp is SSHing into all these nodes. It's starting the systemd units that were already created by the deploy process. So this is all done by creating systemd units, which means that if these nodes restart for any reason, they'll automatically rejoin the cluster. The processes will automatically restart. And that's nice to not have, TiUp doesn't have to maintain a persistent connection to all these backend nodes. It's able to just kind of let them do their own thing. After we've started the cluster, we can look at type cluster display and see the status of the cluster. So that's fantastic. We see all the nodes up and running. Everything's looking great. We have our 6 TiKVs, 3 TiDBs, 3 PDs, and then our Prometheus, Grafana, and Alert Manager. I'm going to start an HA proxy instance to allow us to balance a load across the 3 TiDB server instances. So I have this really simple skeleton of an HA proxy configuration file. And then I have this simple little script. So I'm actually going to use tie-up cluster display test, pipe that through this JQ command. And that'll spit out these really simple pairs of IPs and ports. So if I just do proxy.sh, oops. There we go. Okay, so now we have all 3 of our TiDB servers defined in the HA proxy configuration file. So I can do HA proxy F configuration file and start that up. Great. So now we have our load balancer. We can test that by using the MySQL client, connecting to localhost. Port 4000, we use port 4000 for TiDB instead of port 3306, which is the normal port for MySQL. I'm going to connect as root, and there we are, we're in. And TiDB version, so that's great. So we're all ready to go. We have our cluster running. We are connected to it. So tie-up includes a ton of other things too, in addition to just like the cluster and the playground. Tie-up includes the BR tool, which we use for backups and restores. It includes the CTL suite, which is a bunch of different tools that you can use to connect to the backend components to get information about the running cluster and change some configuration parameters. It also includes our DM component, which is the data migration platform. But it also includes this really cool bench component. So tie-up bench, and tie-up just automatically downloads things when you need them. So we can do tie-up bench, we're going to do TPCC, we're going to prepare, and we'll use 64 threads. So that should be all we need to connect to the local machine by default, which happens to be where our HA proxy is running, and it's going to start firing off the prepare with 64 threads. So let's go back over and take a look in our console and just see kind of what we have going on already now. So we'll probably show process lists will probably be familiar to anyone who's used MySQL. So here we can see there's a number of processes happening, which is not quite as many as we'd expect because we're running 64 threads. The reason is that we have 3 TiDB server instances, and each of them is handling part of the load. So TiDB actually has a bunch of different information schema tables that are extensions to what you would find in MySQL. And one of those is the cluster process list table. So let's select all from cluster process list. And there we see a bunch more stuff, right? So we have 129 rows rather than the 43 that we saw without using that. Some of the other tables in here that are really interesting. So we have the TiKV store status. So the stores are the TiKV instances. And we can see that we have all 6 of those. We can see a little bit of information about each of them. And another thing we can do that's really cool, we can actually see all of the regions. So a region, as you would have learned from Ed's presentation, is how we organize data in TiKV. So all tables, all data is split up into regions, which are typically around 100 megabytes. And if we select from TiKV region status, we can see all of the regions that are in there. So we have 821 regions right now. And you'll see that you can find information about where those are and what they correspond to. So our Ppcc test is going into the test database, which is just the name of the schema. So we can do select all from there where DB name equals test, and then we can actually see how many regions correspond to the load that we're getting from the Ppcc benchmark. So let's now take a look at how we can get a little bit more graphic view of what's happening in the cluster. So if you tie-up cluster display test, we see the Grafana node here. So being able to look at the Grafana dashboard is also going to be really helpful. But then we also have this piece right here. One of the PDs is the leader. That's L. So the PD itself forms a raft group. So there's a leader. But also another one of the PDs has the role of the UI. So that PD component actually it hosts a TiDB dashboard user interface. So we're going to look at both the Grafana dashboard and the TiDB dashboard interfaces. So what we need to do, first of all, is map those internal IP addresses to the external IP that I'll be able to connect to here from my local machine. The Grafana one is on 10.0.21.31. So that's this IP address here. And I'll just flip over and we'll load that up. So I'm just going to log in here with the default. I think I have this battened down, so hopefully nobody's going to try to log in here and mess anything up. I don't think you'll be able to connect, but we'll see. So once you're logged in here, you can get a look at all the dashboards that we ship. So one of the really cool things about a TiDB deployment is every time you deploy, as long as you deploy the Prometheus and Grafana parts of the TiDB stack, you get this huge collection of TiDB dashboards. So we have an overview dashboard, and we have a dashboard for PD. So the PD dashboard is especially useful. This is where we can get a look at kind of the layout of all the data in the cluster. So here we can see there's 6 normal stores. Those are our 6 TiKV server instances. We have, we can see the regions that are in the cluster. We can see the number of regions. And this, of course, will be going up over time as we put more data into the cluster. I bet our prepare step has ended. So let's go see. Let's go run the Ppcc benchmark now. So that'll be putting even more data into the cluster and putting more of a load onto the cluster. So back to the Grafana dashboards. Yeah, like I said, there's just a huge number of these things. So the PD dashboard has all of these different sections. You can see some of these have like 11 panels. Some of them have 14 panels. There's just a huge number of panels. Overview gives you just a little bit more information about all the different components in the cluster and how they're all looking. But then you can go over to do things like look at the TiKV details dashboard. And this is one we often use for debugging, but look at the number of these groups. So we ship a really comprehensive set of Grafana dashboards that are extremely useful whenever you want information about your cluster. And all of this is coming directly from Prometheus, which also is shipped as part of the TiDB stack. So if you have some other graphing thing, or if you want to, get other stuff directly from Prometheus, that's a totally native part of the TiDB deployment. Now let's go look at the TiDB dashboard, which is the one that's hosted by the PD component. That's this one. It's on 10.0.23.98. So 10.0.23.98 is this IP address. Okay, thanks, Google Chrome. Okay, so let's log in here. So we've got this beautiful dashboard. So this is actually a component that we ship. We've maintained this. This is software that we created. So this thing gives you right away a really amazing look at, like, just an overview of QPS. We can see latency, but it also shows us the top SQL statements that are being executed in the cluster. And it also shows, parses, and kind of breaks down the slow query log, which is super useful. We don't have to go use a bunch of tools and collect logs from all the separate TiDB server instances, because each of those is writing its own slow query log. This allows us to actually just see this pulled together into this dashboard. And in each of these, we can see all this information about it. We can see the time it took. It really breaks it down. Coprocessor is something you'll start hearing a lot about as you use TiDB. Coprocessor is the API that's used for communication between TiDB server and a TiKV or TiFlash node. We can even see the query plan. This one's pretty simple, right? This is a really easy point select. But yeah, so this is super great the way we can see all of these flow query details right here in this dashboard. Another really cool thing in here is the key visualizer. So this shows us exactly which keys or ranges of keys are hot at any given time. So if you consider, for example, some table that has an auto increment key, if you're jamming a ton of data into a table with an auto increment, that's gonna be really hot, because the region's always gonna be the same one. So the key visualizer really allows you to identify those situations, and we can kind of burrow down into this and see exactly what range of keys is involved. So this really helps with performance tuning. We can even see basic stuff here about the store topology. So this shows us exactly how the TiKV nodes are spread across the different availability zones that we have instances in. And now that we've gotten to that point, let's actually create some new TiKV nodes, add some more stuff to this running cluster. So we can see over here, we still have our TPCC benchmark is running. And remember, we executed that simple tie-up cluster deploy command to parse our YAML file and copy all the things out to all the nodes that are going to be parts of the cluster. But in addition, I have a scaleout.yaml file. So this file accounts for the various hosts that we haven't yet put anything onto. So I can I'm going to add 4 TiFlash nodes to the cluster, and I'm going to add 2 additional TiKV server nodes to the cluster as it's running. So this is just going to happen without interfering with any load that's on the cluster. And it's as simple as tie-up, cluster, scale out, test, and then I give the name of the file. So tie-up asks me to confirm that I want to put all this stuff on all these hosts. And I'll say, why, yes, I do. That sounds just great. Thank you so much. And it's going to, again, go download all these packages, copy all this stuff out onto all the hosts, and it's going to register all of these with the cluster. And it's going to do that without interfering with the running load. I don't have to reload anything else manually. It's just happening all by tie-up. So while we're waiting for that, I just really encourage you to go check out tie-up, and you can find it easily. Tieup.io is a really easy way to get the information about how to install that. It's a simple thing. Download a script. It's going to download a package, and then the tie-up executable takes care of everything. So of course, tons more documentation about tie-up you'll be able to find in the documentation. So let's see, we're getting there. It's copying some stuff around. So TiFlash is a fairly complicated component. You saw that it has all of these different ports that it's listening on. There's several different things actually running to accommodate a TiFlash deployment. And we will certainly not be getting into all those details today. All right, so it's starting these up, enabling the components. Let's actually go back to our TiDB dashboard and see where we are with that. So if I reload this, hopefully we'll see some of those new items. Hey, there we go. Great. So we have our 2 new TiKV stores in the US West 2D availability zone. We also can see now that we have our 4 TiFlash nodes in the cluster. So what do we do with TiFlash now that we actually have some TiFlash nodes to actually put some stuff on? So the way we're going to make use of TiFlash, we're going to actually alter table. Let's do orders, set TiFlash replica 2. And then we'll do the same for stock. And we'll do the same for history. I'm actually not super familiar with how TPCC uses these tables, so this may or may not be super interesting. So let's just see like a really simple example of how TiFlash might be useful for a really basic query. So if we did something like select count star from orders, what do you think the explain plan for that shows that it's going to be using TiFlash? And the reason is that TiFlash is columnar. So counting the number of things in a table is super fast for TiFlash. Whereas to count the number of rows in a table for TiKV, you have to find the individual regions that are part of that table, and you have to go through each of them to find the number of current valid records. So if we do an explain analyze, that'll show us, that'll actually execute the query and show us what it's doing. So this is showing us that it's sending some stuff out to these different nodes. It shows it's using TiFlash. The formatting of this is not ideal. One thing we can do is we can give a hint, and I know ahead of time that this is not going to work as I want it to, but we're just going to execute it, and then I'll explain why it doesn't work. So we're going to try to get it to read from TiKV for orders. And that doesn't do anything. And the reason for that is that the MySQL client parses out the comments. So whenever you're trying to send a hint, you should make sure you start your client with the comments flag. So now we can see I've actually forced it to use TiKV. So before it was using TiFlash, and now I've told it has to use TiKV, so it's using TiKV to read this. So if I get rid of that, you can see that it is a little bit faster to go to TiFlash. I mean, obviously at this point in this benchmark, we're dealing with relatively low data volumes, but it actually makes a really big difference when you have a lot of data to be able to gather this type of thing from TiFlash instead of from TiKV. So if instead of just counting by orders, what if I group something? So let's see what the orders table has for us to work with. If I group by, I'm not even sure what these columns mean, but let's see what it says it's going to do if I do that. So now we have some new stuff here. We have exchange sender and exchange receiver. Those are actually a part of the MPP, or massively parallel processing feature, that's included in TiFlash. So that means that the individual TiFlash nodes are actually communicating with each other to resolve the grouping. And it means that we can push down the processing power of a query like this across the multiple TiFlash nodes. And you can see the effects of that by, there's a global variable, or rather it can be a session variable. So we can see the TiDB allow MPP, and if we set TiDB allow MPP to off and then do it, see that it's a very different explain, because it's no longer taking advantage of that massive parallel processing. It's forcing a single TiFlash node basically to do this whole work. So this doesn't really give you a flavor of the performance that you're going to see, the performance differences that you might see when using TiFlash versus TiKV, or MPP and TiFlash versus not using MPP. But what I hope this does show you is that I think in about 15 minutes, I've deployed an entire cluster that's across 4 availability zones. We have 4 TiFlash nodes and 2 TiKV nodes that were added to a running cluster, even while the load is still on the cluster. So totally seamlessly. We've been able to see in the dashboards that we can see a lot about what's happening in the cluster. And again, this is all something that we put together in like 15 minutes. So the time it takes to get you actually out and running is so easy. And it's just such a, I don't know, just a super short super short overview of what you can do with TiUp and TiDB. And that's basically what I wanted to show. It was really fast, but I'm super happy to answer any questions anyone has.